Good evening, mathematicians. Tonight we have two learning targets. The first one says, I can multiply a mixed number by a whole number. Remember, a mixed number is a whole number and a fraction. So we're going to be multiplying mixed numbers by whole numbers. Our second learning target says, I can compare the size of a product to the size of its factors. So remember here, product means the answer to a multiplication problem. The factors are the numbers that we multiply together to get the product. Here's our problem. There are 6 students in a literature circle. Each student works for 1.5 hours reading and annotating. What is the total amount of time that the group spends working on their reading and annotations? All right, so I'm going to go back for a second and I'm going to annotate this problem. And here's some important information. I know that there are 6 students. Each student is working for 1.5 hours. And I'm trying to find the total amount of time that the group spends working on their reading. So for me, when I look at this problem, I see something like, so here if I was going to draw a picture, and here are the 6 students, and I know that each of them is working for 1.5 hours, what I might do is do something like this, like 1.5, 1.5, 1.5. And when I write that under each person, what I'm representing is that each person is doing 1.5 hours of work. So for me, when I want to know what's the total amount of time, for me, I would add all of these numbers up together. But what I know about when I do addition with the same number so many times, I know that there's a faster way to do it with multiplication. So instead of writing 1.5 plus 1.5 plus 1.5 plus 1.5 plus 1.5 plus 1.5, I would do 1.5 times, how many people were there? There were 6 people. Well, we've never multiplied a mixed number and a whole number before. Let's try and represent it with a bar model first before we attempt this algorithm. So we know, again, there are 6 students, and each student works for 1.5 hours. So if I was going to represent 1.5 hours with a bar, since I know my denominator is 2, I'm going to show 1.5 hours by shading in both halves of one bar and then another half of another bar, right? So here we actually have 3 halves, right, which is equal to 1.5. So, and each one of these represents 1.5. This represents one student. One student works for 1.5 hours. Well, I don't just have one student, I have 6 students. And the way I could represent this is by doing that same type of representation, but now doing it with 6 different sets of bars. And the reason I'm dividing it in half is because our denominator told us to do that. And to show that each person read for 1.5 hours, I'm going to shade in a full bar, which is 2 halves, plus another half. So each person is really 3 halves of an hour that we're representing. And here are my 6 students, and I'm doing it for all 6 sets of bars, even though each student needed 2 bars to represent 3 halves. So what I can do now is figure out, well, I divided all my bars into halves. How many halves do I have shaded in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 halves shaded in. Well, 18 half hours is equal to 9 hours. So I would think, and we're going to double check it with the algorithm in a second, but according to my bar models, I would think that they spent 9 total hours working on their reading and annotations. Let's try it out with our algorithm. So again, like we said before, we thought that our algorithm might want to do 1.5 times 6, since each student read for 1.5 hours and there were 6 students, that we could multiply 1.5 times 6. Well, there is a tricky, fun little rule that we use for multiplying mixed numbers times whole numbers. What we do is we actually want to turn the mixed number into an improper fraction and then multiply. It'll make it a lot easier. So let's turn 1.5 into a mixed number. Well, I multiply the whole number times the denominator. 1 times 2 is 2. And then I add the numerator. That's 3. And my denominator stays the same. So 1.5 is actually equal to 3 halves. And if we remember, 3 halves is what we represented with the bar. And when we're multiplying by a whole number, we write it as 6 over 1. So 6 wholes is the same thing as writing 6. And now it's super easy to multiply. 3 times 6 is 18. 2 times 1 is 2. And we simplify. How many times does 2 go into 18? 9 times. And if we remember, let's say we have that same equation again, 3 halves times 6 wholes. What we love to do is see if we can simplify before we divide. And 2 and 6 we can simplify. We can divide both by 2. So we end up with 1 and 3. And now if we multiply, we end up with 9 wholes right away, which is equal to 9. So even if we use the bar model or the algorithm, and remember with the algorithm, we want to turn our mixed number into an improper fraction and then turn that whole number into something over 1, make it super easy to multiply, and we want to make sure that we write our units. It's 9 what? 9 hours that the group was working together on their reading and annotations. Good luck!